Today we're looking at flat rate and unit cost depreciation. So depreciation is the amount of decrease in value of, say, a particular item. In the examples here, they're using computers, tablets, cars can also depreciate. It's generally due to age. Sometimes it's due to amount of use or generally a lack of demand. And so businesses will use a depreciation schedule to figure out exactly how much they have as a net worth. So we're going to have a look. We can find that the future value of an item will be equal to its purchase price, subtract its depreciation. And there's three ways that depreciation can occur in assets: as a flat rate, a unit cost, or reducing balance depreciation. So we're going to have a look at flat rate depreciation, and we're using recurrence relations to do that, and then we'll have a quick look at the other two as well. So flat rate depreciation, which is a straight line depreciation, is calculated by finding the future value of an asset and how much it's reduced by each year. So our first example is a ride-on mower. It's purchased by a gardening business for $9,500, and it depreciates at a flat rate of 5% per annum every year. So we need to fill out this table. Initial value is $9,500 or at time or year zero. After year one, we find, so we're actually going to find out the depreciation is 5%, and we can find that 5% of 9,500 is $475. So we subtract that amount off the initial amount and we get $9,025. After year two, we use the value at the end of year one and we subtract $475 to get our $8,550, and we continue that each year. So after 5 years, we find that the value of the mower is $7,125. Right, so section B is asking us to then write a recurrence relation for the future value of the ride-on mower and what shape the graph would be. Now, it kind of gives us a bit of a hint when it's talking about a straight line or a flat rate, so we should expect the graph to be straight line. But if we're writing a recurrence relation, we use the initial value of 9,500, comma, the value that we're looking for, the value after so many years, is equal to the value of the year before it, subtract $475. So you can see that, you can do that over the first few years. We've got the value after so many years equal to 9,500, subtract the number of years times 475. So we can see that, we're going to use the initial amount each time. Let's have a look. After 3 years, you can see 9,500, and then we're taking 3 times 475. So you can say 1, 2, 3. So you can sort of see how that's working there. D then talks about, we can't continue doing this. It's not really sustainable. We need to use that general formula now. So we're going to say, n is now 15. So the value of n, or value after 15 years, is 9,500. Take 15 times that 475. And that value would then be 2,375 after 15 years. So all these are just showing the general formulas here, our recurrence relation. Our D, or our depreciation, is calculated by using that flat rate of depreciation, so generally in percent, over 100 times by the initial amount. And you can see that there, or you may find that it also talks about n being the number of time periods. Most of the time it's in years, but it may be in quarterly increments as well, or monthly increments, however, whatever the question's asking. So example 2 talks about Shane being paid $50,000 for a new computer at the start of 2012. he used the flat rate depreciation to revalue the equipment, and at the start of 2016, he revalued it at $28,000. So, what is the dollar amount of depreciation from 2012 to 2016? So, we use depreciation is equal to the start minus the end value, and we find 50,000 take 28,000 is $22,000. So that's the actual depreciation in 4 years that's happened. Then it asks what was the annual flat rate. So we use, first step we need to do is find the depreciation per time period and then find out the percentage. So the rate at 2016 was 28,000 is equal to the initial rate, take 4, so there were 4 years between 2012 and 2016, and then to find D, we can use solve note calculator, so remember comma D, you get 5,500 per year every year. So the second step, once you've found that, is using that depreciation here and finding the actual rate. So we put that into our general formula here, times it by the initial value, divide by 100, and you'll find that the flat rate of depreciation is 11% per year.